This lesson, we're going to learn how to derive the differentiation rules for trigonometry. One way to do it is do it directly from the graph. So the first thing we do is to identify the points where the slope of tangent line will be 0. So it will be here, and here, and here, and here, and here, and here, which is all the maximum and minimum points. So the first function here is called fx, and this grid will be called f prime x. So since we know at those maximum minimum points, slope of tangent will be 0, so that means at this point will be the 0. Will be a 0 here, will be a 0 here, will be the 0 here, will be the 0 here, will be the 0 here. Because f prime means the slope of the tangent at that point. So that means at this point, slope of tangent is 0. So that's why 0. At this point, slope of tangent will be 0. As the next step, we have to find out what will happen to the graph in between all the zeros here. That means we have to use tangent line to help us to find the slope along the curve. So the best way to do it is in between all the maximum minimum, we're going to use 3 points to approximate the tangent line. So one will be here, one will be right in the middle, one will be another one. However, because in the middle, the point in the middle will have the steepest line for the tangent line. So we're going to find the slope of this tangent line first. So let's put the point here, and let's draw a tangent line. After you draw the tangent line, then you make a right triangle, which is right triangle, to find the rise over wrong, to find the slope. And now let's calculate the rise and wrong. So our wrong is actually 1 pi. And our rise is approximately 3. So from doing the rise over wrong, we will do 3 over pi, which is going to be almost 1. Likewise, let's do a tangent line at this point. And if you draw a tangent line and you calculate the rise over wrong, you will see the slope is approximately -1. And then at this point again, that will be +1 again. And at this point again, that will be a -1 again. So as we continue on, you will see a new sinusoidal function. After connecting all the points using a very smooth curved line, we actually can see the resulted function is a cosine function, which means if the original function is a sine function, then the differentiation of the sine function will become a cosine function. Therefore, we say the derivative of sine x will become cos x. So if this fx equals to sine x, f prime x will become cosine x. Now let's take a look at this function now. So original function now is going to be a cosine function. And we do the same thing. First of all, at all the maximum and minimum, the slope of a tangent at those points will become 0. And in between the maximum and minimum, at this point here, because slope of a tangent is actually negative as the tangent line is pointing down to the right. And if we do a right triangle, you will see again the rise over wrong will be approximately -1 again. So we know the slope of tangent is -1. And in between the minimum and the maximum, this point, the green point here, if you do a tangent line again, and if you do the rise over wrong, you will see the slope of tangent is approximately 1 again. Let's continue on with this trend, -1, and this point will be +1, and let's connect all the points together. Let's see what kind of function do we have. After connecting all the points, now we see a function that is very similar to sine, but just reflected around the x-axis. So we call this function negative sine x. So now we know the derivative of the cosine function will become negative sine. So now we know differentiation sign will become cosine, and the differentiation of the cosine will become negative sign. And that's use those two rules to derive all the differentiation rules for the remaining trigonometry function. So the first one we're going to do is we're going to find the differentiation rule for tangent. But we cannot use tangent, so we have to write it sine and cosine, because that's the only two rules we know. So tangent is sine over cosine. And then we're going to use the quotient rule to find the differentiation rules. So denominator square, and differentiate numerator, sine will become cosine, times by the denominator, which is cosine, minus numerator, which is sine, and times by differentiation of the denominator, which is negative sine. Then we're going to have cos square x plus sine square x and we know from the Pythagorean identity, cos square plus sine square is 1. So we can write 1 over cos x squared. And 1 over cosine is secant, so this will become secant square. So differentiation tangent will become secant square x. Next, we're going to do differentiation of cotangent. Once again, we write cotangent into cosine over sine. And that's use the quotient rule again. First, denominator square. Differentiation numerator, negative sine x, times by the denominator, minus the numerator, times by differentiation of the denominator. Now you're going to have negative sine square x minus cos square x over sine square x. And once again, this is actually negative sine square plus cos square x. And we know sine square x plus cos square x is 1, which is negative 1 over sine square x, which is negative cosecant square x. Next, we're going to derive the rules for secant. Secant is 1 over cosine. So I actually can write as cos x to the exponent negative 1 and use the chain rule to derive it. It will be easier. So y prime will become negative cos x to the power negative 2, differentiation base, so differentiation of the cosine will become negative sine. Because since we have two negative sign will become positive, then you have cos x negative 2 times by sine x. That means we're going to have sine x on the numerator, and there's a 2 cosine x in the denominator. And we know sine x over cos x is tangent x, and 1 over cosine is actually 1 over secant. So the differentiation rule will become tangent x times by secant x. Similarly, we can do cosecant as 1 over sine x. And I can write as sine x whole thing to the power negative 1. So my differentiation using the chain rule will be negative sine x to the exponent negative 2. Differentiation base means differentiation sign, which is cosine. Then I can write as negative sine x, 2 of them in the denominator, cos x on the numerator. Now let's take a look. Cosine over sine means cotangent. And this means 1 over sine on the side, which is cosecant. So my differentiation will become negative cotangent x, cosecant x. So now let's make a summary. For any kind of function that doesn't start with a c, I know the differentiation will be positive. For any trig function that start with a c, like cosine, cotangent, cosecant, I know the differentiation will have a negative sign in front of it. So now let's take a look. What if the angle inside a trigonometry function, it's not just 1x? Then similarly to the other differentiation rules, whenever the angle is not just x, then you need to times by the differentiation of the angle. So let's try this. So for part A, for example 2, you have fx equals to cosine 3x. So first thing we know, differentiation of a cosine will become negative sine. So that's the first thing we write it down. So we write down f prime equals to negative sine and copy the angle down. Don't change the angle. And then you're going to multiply differentiation of the angle. So you look at the angle 3x, and differentiation of the angle means differentiation of 3x, which is a 3. So I need to multiply a 3. And that's putting in the bracket. And then let's combine them. Put the coefficient in the front. So we do negative 3 sine 3x. For part B, now the angle is x. However, it's more than just one trig functions. Then you have to use product rule. So as you can see here, my u is actually x. And my v is sine x. There are two functions now. So my u prime will become 1. My v prime will become cosine x. And now that's put into product rule. So g prime equals to u prime v plus u v prime. And that's substitute in. So u prime is 1, v is sine x, plus u, which is x, and v prime is cosine x. Now, my differentiation is done to simplify it. So sine x plus x cosine x. Since there's nothing in common, we cannot common factor them. So this is going to be your differentiation. For example number 3, I want to show you the difference between those two functions. One exponent in the middle and one exponent on the side. So let's look at part A. Y equals to sine x squared. So that exponent only applies to the x. So when we do the differentiation, we will do this. Differentiation sine will become cosine. And write down the angle. Don't change the angle. And then we have to multiply by differentiation of the angle, which is differentiation x squared, which is 2x. So your differentiation will be 2x times by cosine x squared. For part B, this really means this. Y equals to sine x, the whole thing square. So whenever you see the exponent is in the middle, that means the whole thing square. So when I do the differentiation, it actually applies to the chain rule. So you bring down exponent 2, don't change the base, to the exponent 2 minus 1 is 1, and then you times by differentiation of the base. So differentiation of sine will become cosine. So now you have y prime equals to 2 sine x cos x. And we know this is actually double angle for sine. So the simplified way to write it will be sine 2x. In order to differentiate the trigonometry function effectively, there are some identities that we have to remember. The first one is called tangent and cotangent identities. So tangent theta can be written as sine theta over cosine theta. Cotangent theta can be written as cosine theta over sine theta. And all the reciprocal identities, that means cosecant theta is 1 over sine theta, and secant theta is 1 over cosine theta, and cotangent theta is 1 over tangent theta. The next set of very important identities is called Pythagorean identities. So we know sine squared theta plus cos squared theta, it's always 1 if they have the same angle. So if you divide those three terms by cosine squared, sine squared divided by cos squared, you will get tangent squared. Cos squared divided by cos squared, you will get 1. And 1 divided by cos squared, you get secant squared. So that's the second Pythagorean identities. The third one is I divide those three terms by sine squared. So sine squared divided by sine squared, you get 1. And cos squared divided by sine squared, you get cotangent squared. And 1 divided by sine squared, you will get cosecant squared. So that's a third Pythagorean identity. Now, we're moving on to the last set. So the last one that is very important is called double angle formula. You definitely need to know what's sine 2 theta, which is 2 sine theta, cosine theta, and the 3 different formats for cosine 2 theta. So once we know all those identities, then a lot of trigonometry functions can be simplified before you differentiate it. Now let's try to differentiate more trigonometry functions. So part A, y prime will be, first thing, you differentiate the cosine, which will become negative sine. Copy down the angle doesn't change, times by differentiation the angle, which is 3x squared. And then we will write y prime will be negative 3x squared sine 1 plus x cubed. For part B, you can see the function is sine squared theta plus cos squared theta. They both have the same angle. That means this is a Pythagorean identity. So I can simplify the function into y equals to 1. So my differentiation y prime will be 0. For part C, you can see this is actually an exponential function because the variable is in the exponent. So first thing we do is y prime, copy down the entire exponential function, don't change it. And then we have to differentiate the exponent. So when we differentiate exponent, we can see this is trigonometry function. So differentiation sign will become cosine. And copy down the angle, don't change the angle. And then the next thing is we have to differentiate the angle. So that becomes a power rule. Square root of x means x to the power half. So you bring down exponent half. X to the exponent half minus 1 will be negative half. And then we simplify then by putting them into a fraction because we don't want negative exponents. So that over 2 and x, because the exponent is negative half right here, so we have to put them in the denominator. Part D, this is a fraction, so we're going to use a quotient rule. So y prime will become denominator square, differentiation numerator, which is differentiate tangent, which is secant square x, times by the denominator, minus the numerator times by the differentiation denominator, which is 1. So we can simplify to this. For some people, they would like you to simplify further. So what does that mean? That means they don't want to see tangent and secant. They always want to see sine and cosine. So you could change to this. X over cos square x minus sine over cosine. But in order for me to combine the numerator, I need to have the same denominator. So I'm going to times by another cosine. So then the denominator will become cos square x again, divided by x squared. So there is not a form you can write it. You can write x minus sine x cos x over cos square x, and divided by x squared means times by 1 over x squared means x squared in the front. And that's another format. For E, if you look at it closely, this is actually double angle for cosine. So I can simplify the function y into cosine 2 times by 5x, which means this is cosine 10x. And then I can differentiate it. So cosine becomes negative sine times by differentiation of angle, which is 10. And now it will become negative 10 sine 10x. Last part, f. Once again, that's an exponential function. So y prime, first thing is copy down exponential function, don't change anything. And then you have to times by differentiation of the exponent. So which is sine becomes cosine, cosine becomes negative sine. And that will be your differentiation. For example number 5, the trigonometry function becomes a little bit more complicated because either they are being combined with other functions or there are more trigs being composed together. So let's look at part A. So if you see this, actually there are two functions being multiplied together. So that's our u, that's our v. So let's define them. U is x cubed. So I know my u prime will be 3x squared. My v will be cosine 1 over x. So I will write cosine x to the exponent -1. So my v prime will be differentiation cosine will become negative sine. And copy down the angle, doesn't change. And differentiation angle will become negative x to the exponent -2. Now, let's put them into the product rule. So u prime times by v plus u times by v prime. V prime, because there's a negative, it will become a positive. So I will just write x to the power -2 sine 1 over x. Now let's simplify it. When you multiply those two powers, you add the exponents together. So 3 plus -2, which just becomes x to the exponent 1. And now, what do they have in common? They have x in common. So let's factor out the x. And that's our final answer. For part B, you can see this is chain rule. So first thing, y prime. We bring down the exponent and don't change inside the square bracket. Just copy it. And the exponent -1 minus 1 will become -2. And you do a big pink bracket. That means the differentiation of the square bracket will goes into the pink bracket. And the next thing we see is differentiation of the tangent. So differentiation of tangent is secant square. So we write down secant square and copy down the angle, doesn't change it. And then you do a big purple bracket. That means differentiation of the angle will goes into the purple bracket. Now, let's look at differentiation of the cosine, which is negative sine. So we do negative sine. And copy down the angle, doesn't change, and do another open bracket for differentiation of the angle. And we know the differentiation of the angle is 2x because the angle is x squared. And that will be our differentiation. So now, all we left to do is just to change all the negative exponents into positive. So let's do a long division sign. And negative is outside the fraction. This negative exponent here, that means this square bracket here goes in the denominator. So tangent bracket cosine x squared to the exponent 2. And then the other pink square bracket here, that goes on the numerator. So just copy it. So we do secant square cos x squared. And times by, now let's simplify this purple bracket here. So because this is like individual term, so I'm going to write it in front of it. So it's going to be negative 2x and sine x squared. And that will be the simplified form. And now we are finding the equation of a tangent line to a curve at the x values at pi over 2. So equation of a tangent means we have to find the slope first. If I want to find the slope, that means I have to find y prime. So let's do y prime. But before I can do y prime, I can see this is a product of two functions. So u is your x and v is your cos 2x. So that's defined it. So u is x, so u prime will be 1. V equals to cos 2x. So v prime will be, differential cosine will be negative sine. Copy down the angle, doesn't change. And times by differentiation angle, which is 2. And then that's put into the product rule. So y prime will become u prime and v plus u times by v prime, which is negative 2 sine 2x. And then let's substitute our x value in there to find our slope. So at x equals to pi over 2, your y prime, which is the slope, equals to cosine 2 times by pi over 2, which is pi, plus pi over 2 times by negative 2 sine, once again, 2 times by pi over 2 will become pi. And we know by using the unit circle, at this point, it's going to be negative 1 and 0. Negative 1 is your cosine pi, and 0 is your sine pi. So let's substitute the values in. So cosine pi is negative 1 plus pi over 2 times by negative 2 times by sine pi, which is 0. So slope is going to be negative 1. So now we have the x, we have the slope. All I need is the y. So we have to put into this function to find y because we have the x. So y will be pi over 2 cosine 2 times by pi over 2 again, which is pi. So cosine pi. And we know cosine pi is negative 1. So my y value will be pi over 2, negative. Now, let's substitute everything we know into the slope formula to find equation of the tangent line in standard form. So substitute the point pi over 2, negative pi over 2, and the slope m equals negative 1 into m equals 2, y2 minus y1, x2 minus x1. So we know slope is negative 1, y minus negative pi over 2, x minus pi over 2. So cross multiply, you get negative x plus pi over 2 equals to y plus pi over 2. So 0 equals to x plus y. Therefore, your equation of the tangent x plus y equals 0. Since all the differentiation rules should be derived from the first principle, so here I want to show you how to derive the differentiation rules for trigonometry from the first principle. Given fx equals to sine x. So using the first differentiation, f prime x will be limit h is approaching to 0, f of x plus h minus f of x divided by h. And we're going to substitute in f of x plus h will become sine x plus h minus sine x divided by h. And using the compound angle formula, we know sine x plus h will be sine x cos h plus cos x sine h minus sine x divided by h. And then we're going to combine the first and the third term together and common factor out the sine. Then we're going to use property limits. Break them into many different parts. And now I have to introduce two very important identity. Limit x is approaching to 0, sine x over x will be 1. And there's another one, limit x is approaching to 0, cos x minus 1 over x will be 0. So now let's take a look. If I replace the x with the h, that will be limit h is approaching to 0, sine h over h. That will be a 1. That means this square bracket will be a 1. Next one, if I replace x with a h, then you have limit h is approaching to 0, cos h minus 1 divided by h will be 0. That means this square bracket here will become a 0. So now let's substitute the values in. So limit h is approaching to 0 sine x, because there's no h, so the function will just become sine x. And the next square bracket, because the property, we know this is a 0. Plus, now once again, there is no h here. So when limit h is approaching to 0, the square bracket just becomes cos x. And because of the property here, so we know this square bracket becomes a 1, so we times by a 1. So now you can see the differentiation will become cos x. So once again, all the differentiation rules, you can just think of that's a shortcut to differentiate the function. That means to find the slope of a tangent by using the first principle.